Alright, this video is going to be on separable equations. So number one is show that this equation is separable. So what we're going to do is we're going to want to isolate dy dx and set it equal to everything else basically. So we can do dy dx. We're going to divide by x plus 1, so we're going to have xy over x plus 1 equal to y over x plus 1. And now we can move over xy over x plus 1 to the other side. So dy over dx is equal to y over x plus 1 minus xy over x plus 1. And if you notice, this is the same denominator, so you can just make it into one fraction. And you have dy over dx is equal to this fraction. And now you can just cross multiply, so this will become x plus 1 dy is equal to y minus xy dx. So I'm going to erase the top here, and we're going to be left with this. So we can say dy x plus 1 is equal, we could factor out the y, so we have y times 1 minus x dx. And remember, we want the same variables with each other, so we have dy over y equal to 1 minus x dx over x plus 1. So here we showed that it's separable. So for number 2 here, we want to find the general solution. So first we could show that it's separable. So once again, let's do dy over dx by itself minus xy over x squared plus 1, and then minus x over x squared plus 1 equal to 0. So we move everything to the other side, so dy over dx is equal to, since it has the same denominator, when you add it to the other side, you're going to have xy plus x over x squared plus 1. If you were to cross multiply, so x squared plus 1 times dy equal to xy plus x times dx. However, you could factor out the x, so let's take this out. And we're left with y plus 1 here, and the x right here. And finally, we can do dy over y plus 1 equal to x dx over x squared plus 1. Alright, so now we integrate both sides to solve the differential equation. So here would be a quick u sub if you want to write it out. So du is equal to dy. So here the u sub would be du over u. And then over here is another u sub, so we can call it v. So v is equal to x squared plus 1, and dv gives you 2x dx. So we divide by 2 so that we could replace the x and the dx. So dv over 2 is now equal to x dx. So this equation becomes 1/2 dv over v. So now, simplifying all this, the derivative of 1 over u would just be ln u, but we know u is y plus 1, so we just write ln of y plus 1, and set it equal to 1/2 ln of x squared plus 1 plus c. Alright, to simplify this, we e both sides. So e, because it's a natural log, they read inverse each other. So this would just become y plus 1 is equal to, so this 1/2 could come up because it's a logarithm, or natural log. So it'll be e to the ln of x squared plus 1 to the 1/2. This was a bit plus. And plus c is also part of this exponent. So the e undoes the log, the natural log, so it'll just be x squared plus 1 to the 1/2. And then you're left with times e to the c. So times e to the c. But this e to the c could just be called c1. So you could rewrite this whole thing as y is equal to x squared plus 1 1/2, multiply it by c1, and subtract the 1, because this is supposed to be a plus. My apologies. And this is your general solution. Alright, so number 3 is solve the initial value problem. And we're giving y prime, but we could rewrite it as dy dx. So dy dx. And now we can separate them. So dy times 2 y minus 1 is equal to 3x squared plus 4x plus 2 dx. And now we want to integrate both sides. So let me write this a little more clear. So now we can use this u substitution, because if we don't use this u substitution here, you don't have to use u substitution, but if you don't, you can't really solve for y's in the end. So we're going to use u substitution because it's a lot nicer. The problem goes on a lot nicer. So we're going to say u is equal to y minus 1. Du is just dy. So this becomes 2u du, which is just u squared over 2. But we know u squared is y minus 1 squared. And set it equal. So this side just becomes 3x cubed over 3 plus 4x squared. So it would be 2x squared, and then plus 2x, and then plus c. So this goes over here. And now we can solve for c. So for solving for c, we're going to use the initial value they gave us, y of 0 is equal to negative 1. So we're going to say, we're going to plug in 0 wherever there's x, so 0 plus 0 plus 0 plus c. And then y is negative 1 because of this initial value. So negative 1 minus 1 is negative 2, but negative 2 squared is 4. So 4 is equal to c. So now we can rewrite the equation as y minus 1 squared is equal to x cubed plus 2x squared plus 2x plus 4. Furthermore, we can take the square root, so we have y minus 1 is equal to plus or minus square root of all of this, plus 2x plus 4. Oh my gosh, my plus signs are not coming out very well. And finally, we just move the 1 to the other side. So instead of rewriting the whole thing, I'm going to just move the 1. So y is equal to this, plus 1. And for the IVP, we actually need to pick one of the solutions, because we have 2 solutions here. So we need to pick one of them, because only one of them is going to work. So we do that by just using the IVP they gave us, the initial value. So negative 1 is equal to plus or minus the square root. So plug in 0 plus 0 plus 0 plus 4, and then plus 1. So over here, we're going to try out the negative, or let's try out the positive. So we're going to use the positive root. So this becomes root 2, well root 4 is 2 plus 1, that gives you 3, and that is not equal to negative 1, according to this side. So it has to be the negative. So our solution is y is equal to negative root x cubed plus 2x squared plus 2x plus 4, and then plus 1. That's our answer. Alright, so this is number 4. You can pause the video and give it a try yourself. So moving along, we could turn y prime to dy dx because we want to separate them. So dy dx. And we have the root x squared minus 1, but I'm going to just bring it to the other side now. So we have y cubed times x, that's supposed to be a dot, over x squared minus 1. And now we just move over the variables. So we want the y's to be together, so we do dy over y cubed is equal to x dx over root x squared minus 1. So now we're integrating. Y cubed is just the power rule, and x squared minus 1 is a u sub. So we do u is equal to x squared minus 1. That means du is equal to 2x dx. Over here, the power rule would just be, this is y to the negative 3, right? So y to the negative 3 dy. So this just becomes y to the negative 2 over negative 2 equals to, so we have 1 over, we divide by 2 here, and this will just be x. So now we could replace this x dx with du over 2, so it's equal 1/2 du over root u, which is u to a half. So this could be rewritten as 1/2 integral of u to the minus a half du. So to integrate this, it would be another power rule. So let's rewrite this whole thing as minus 1 over 2y squared, which is equal to 1/2 u to a half over a half, and then plus c. And that's because we integrated from the integral. Because negative a half, so we have the integral of u to the negative a half, so negative a half plus 1 over negative a half plus 1, which is just a half. So this is how we got this part. And then these two halves cancel. So since we replaced u with x squared minus 1, let's resubstitute that back in. So to also simplify further, 1 over y squared is equal to minus 2, because we multiply from this 2 over here, and then times the root of x squared minus 1 plus c. So now we could solve for c by using the initial value they gave us. So let's plug in 1 for y and 2 for x. So we have 1 is equal to minus 2, and then 2 squared is 4, minus 1 is 3, so root 3 plus c. And then we are left over with 1 equal to minus 2 root 3, and then minus 2c. So we want to isolate this c, so we say 2c is equal to minus 2 root 3, and then minus 1. And then you divide by 2, so c is equal to minus root 3 minus a half. So now we can rewrite the entire equation. So we had 1 over y squared, which is equal to minus 2 root x squared minus 1. And we said c was minus root 3 minus a half. So now we could just flip both sides so that we could isolate the y. So y squared is equal to 1 over minus 2 root x squared minus 1 minus root 3 minus a half. And we're going to take the square root, and that will give us two solutions because of the plus or minus. And once again, we only could use one solution. Only one of them is going to work. So let's test out the positive solution. So we're going to plug in the initial value. 1 is equal to the positive square root of 1 over minus, we're going to plug in 2 for x. So minus 2 root 3. Leave parentheses here. Minus root 3 minus a half. And that will leave us with 1 is equal to the positive root of 1 over 1. And this is just 1. So this solution is correct. So our actual solution is just y is equal to the positive root of this.